Hello class, this is a video tutorial on the arc length of a sector using radians. To calculate the arc length of a sector, we require two pieces of information, the radius and the angle subtended. Before we continue, this idea of subtended means the angle formed by two straight lines. So the angle subtended here is this theta, and the two straight lines it's referring to are the two radii that form that angle. And so to calculate the purple curved length, it's calculated as theta on 360 times the circumference of the circle. And this is how we've done it back in stage 5. That's years 9 and 10. And here's a quick example of this. If we have a 30-degree angle subtended, so 30 on 360, that will simplify to 1/12. 2 times 5 is 10 pi. And if we just keep this in exact form, 10 on 12 becomes 5 pi on 6 because of the pi there. However, in using radians, the angle is already a fraction of a whole circle. So the formula of an arc length is given as L is equal to R phi, given that phi is in radians. Okay, now this might not make as much sense, but you'll see what we mean in a moment. So calculate the arc length of the following. So we have a radius of 5, and the angle subtended is pi on 6. In case you're wondering, pi on 6 is actually 30 degrees, which this is the exact same as this one. So the answer that we get should be this exact same one here. Let's take a look at what happens. So the arc length, L, is given as r theta, which is 5 times pi on 6. And would you take a look? It's going to be 5 pi on 6 units, which is the exact same that we got in the previous example. Let's delete that one, not necessary. Now we could do this in degrees, but let's practice this using radians. So for this, we're going to convert 135 first into radians. So it's going to be 135 times pi on 180 radians. That's going to be, let's take a look, 135 on 180. And that fraction is 0.75, which is 3 pi on 4. Now that we have that angle, L is given as r theta or r phi, or whatever the angle might be. In this case, our radius is 10 times our angle, 3 pi on 4. Simplifying this, dividing both by 2, this will give me 15 pi on 2 in units. Obviously, if this were in centimeters, you would write this as centimeters. Let's do this one more time. Now let's take a look here. For this example, we're given this angle on the outside of the sector. What we really need is this angle here, angle theta. That's because we want to calculate that curve length along the edge. Now to calculate that angle, well, let's consider that the full circle is 360 degrees. And 360 degrees, if we divide that by 180 times pi, is actually equal to 2 pi radians. So this entire circle here should be equal to 2 pi. Well, because we have 1.92, we can say theta is equal to 2 pi minus 1.92. So 2 pi minus 1.92. That gives us 4.363185, taking as many decimal places as possible in order to keep this accurate. And now, since we have this as our radians, we can calculate now the arc length here. So L is equal to theta times the radius. The radius is 2. So it's going to be 2 times our angle in radians, 4.363185. And taking this answer here and multiplying that by 2. That's equal to 8.73 units. So that's how we calculate the arc length. But let's extend this a little bit further to calculate the perimeter of the following sectors. So the reason why I'm showing you this is that this formula, L equals R theta or phi or whatever symbol you'd like, only calculates this curved edge. When asked to calculate the perimeter, we require every edge part of the circle. So in this case, the perimeter P is equal to L plus 2 times the radius. But we've already calculated the value of L in this. That's 5 pi on 6. So 5 pi on 6 plus 10, which is approximately equal to that's equal to 12.62 units. In this case, it's the same thing. The perimeter is equal to the arc length L plus 2 times 10, because the radius is 10. And we know what the value of the arc length is. It's up there. So 15 pi on 2 plus 20. 15 pi on 2 plus 20 is equal to 43.56 units. And one last time, our perimeter here is 8.73. That's the value of L previously calculated, plus 2 lots of the radius of 2. That's 8.73 plus 4 gives us 12.73 units. So I hope that gave you an insight into calculating the arc length of a sector using radians, as well as extending this a little bit further to calculate the perimeter of sectors. Hope to see you in the next video. Best of luck.